And then you know the vapor pressure of your ethanol is 4.914 kilopascal. And the pressure for your H2O is equal to 2.305 kilopascal. Okay. You also know your P ethanol star is 7.893 kilopascal, and the P star for your H2O is 3.169 kilopascal. Okay, and you want to know your A and gamma. Okay, you want to know your A ethanol, A water, and the gamma ethanol, gamma H2O. Okay, so these are the four quantities you want to calculate. Okay. So the way I will do is actually, so we know the definition of A and gamma, right? A is actually your real versus your reference state, and the gamma is real versus your ideal. Okay, so if you look at the ethanol, so this is your real, right? So these two is the real, and this two is your reference state. Okay, so with this concept in mind, you know your real for your ethanol is 4.914, and your reference is 7.893. And this gives you a number of 0.6226. Okay, that's for your A ethanol. Okay, and your A water, A H2O is going to equals to the vapor pressure of your H2O is 2.305, 2.305, and your reference state is 3.169. Okay, and this gives you a number of 0.7274. Okay. So if you want to calculate gamma is the real versus ideal. Okay, in this case will be the vapor pressure of the ideal solution, right? So your real will still be 4.914, and your ideal will be P ethanol star times your X ethanol. Okay, so there will be 4.914 divided by 7.893 times your mole fraction, which is 0.5. And this gives you a number of 1.245. That's for your ethanol. Okay. And the gamma for your H2O will equals to, your real is 2.305. Your ideal will be 3.169 times also 0.5. And this gives you a number of 1.455. Okay? So let's go question number 1. Basically, the concept you should have is actually A is your real number compared to the reference number. The gamma is your real value compared to the ideal solution condition. Okay. Okay, question number 2. Okay, at 81 degrees C, the equilibrium vapor pressure of toluene, so P toluene is going to equals to 39 kilopascal. And the P benzene is equal to 102.4 kilopascal. Okay. So what is the, we want to calculate first the P total at this temperature when the mole fraction of the solution is 0.5. Okay. And the second is, what is the XBV? Okay, so basically the benzene, what's the mole fraction of benzene in the vapor phase? So if you want to calculate XB in the vapor phase. This is P star, just pure toluene and pure benzene. So in the question here, we have actually P toluene star and P benzene star. Okay. So the total pressure, we said the P total is equal to summation of Pi star times your Xi. So in this case, the I equals toluene and benzene, right? And the Xi, since XB is equals to 0.5, then you know your X toluene is also equals to 0.5. Okay? So this will be equals to your P star toluene times the mole fraction of toluene plus the P star of your benzene times the mole fraction of your benzene. So this will equals to 39 times 0.5 plus 102.4 times 0.5. Okay, if you calculate this, this will give you a number of 70.7 kilopascal. So the second question is actually, what is the X benzene in the vapor phase? So this will equals to what is the vapor pressure of benzene compared to the total vapor pressure. Okay, so P benzene is equals to P benzene star times the mole fraction of the benzene in the solution divided by the total pressure, which is 70.7. So the things on the top will be is 102.4 times 0.5 divided by 70.7. That gives a number of 0.7242. Okay, and that's the total pressure of the system. Okay. All right, question number 3. Okay, compute the concentration of dissolved O2 in water at 25 degrees C in equilibrium with air, where the PO2 equals 0.2 atm, and the Paris constant for the O2 is 773. Okay, so how to calculate this? This is exactly the same as the example we have in the class, right? So you know you need to use Paris law, where the PO2 is equals to the Henry's constant of your O2 times the concentration of O2 in the solution, or the solubility of O2 in the solution. Okay, so your P is 0.2 atm, and your K is 773, and the M O2, the concentration of dissolved O2 in water is essential to solve. So your MO2 is going to be equals to 0.2 divided by 773, which gives you a number around 2.5 times 10 to the negative 4. Okay, so the unit will be moles times per kilogram of water. Right. So let's go on number 3. Okay, for number 4, you have a mixture of chlorine and the acetone and the to look at the question again. Mixture of trichromazane. Okay, trichromazane. And the acetone. So you have a solution of these mixtures. Okay. So the things you know, you have the mole fractions of acetone is equals to 0.713. Okay, and this also tells you the mole fraction of your trichloromethane is 1 minus 0.713, which equals to 0.287. Okay. And it also tells you the Y acetone. So one acetone basically is just the mole fraction of acetone in the vapor phase. Okay, and this is going to be equals to 0.818. Okay, and then also tells you your trichromazane in the vapor phase, mole fraction for that is 0.182. Okay. So what you want to calculate is the activity and activity coefficient A of your trichromazane, right? And the gamma of your trichromazane, assuming it's an ideal solution. Okay, and it also tells you the P star for your trichromazane equals to 200.5. Sorry, 221.8. Okay. So that's the question. Okay. Okay, so let's talk about the question again. Okay, so you have a solution contains of two different components. One is trichloromethane, the other one is acetone. Okay, when you mix them together, then you know in your solution, inside your solution, the mole fraction of your acetone is this much, then you know the mole fraction for the other component is this much. Okay? And then in the gas phase, so this is inside the solution, right? This is in the vapor phase. In the vapor phase, you know your mole fraction for your acetone is this much. And therefore you know for your trichromazane they will be that much. Okay, this is 1 minus this, you get this. Okay, you also know your P trichromazane, P star is this much. You want to know your P total. Okay, and you want to know your A and gamma for your trichromazane. How do you do that? Okay, so the first thing I will do is actually trying to just write this down. Okay, the real over reference state, the real for the ideal condition. Okay, so your real is basically your pressure of your trichromazane, right? And this will be your P star of your trichromazane. Okay, and this will be P real for your trichromazane, and bottom will be P star of your trichromazane times your X trichromazane in the solution. Okay? So how do you figure out the P, the real, basically this guy, you want to figure out this guy, right? Because you already know this. You already know this. If you know this, you know the answer, right? This is fine. You don't know this, you need to know this guy to calculate your A and gamma. Okay? How do you calculate your P total? How do you calculate your P total? Oh, the P total is given in the question. Yes. The P total is okay. So actually, you have the P total in your question already. Okay, so I guess this makes our life a lot easier. Okay, so you don't need this because you already know the answers. Now the question is actually, can you figure out what's the P trichromazane in the system? Okay, so how do you figure that out? Okay, so it actually coming from this. Okay, so the mole fractions of trichromazane in the vapor phase is actually defined as the vapor pressure of trichromazane over the P total, right? And you know this guy because it's here. Okay, so you know the left-hand side is 0.182. Okay, P trichromazane is the things you are looking for. Okay, P total, you actually know the number because it's provided inside the question. So P total is equals to 220.5. So from here you know your P trichromazane is going to equals to this multiplied by this. And they give you a number of 40.5 0.13. Okay? So once you know that, then everything becomes very easy, right? Because you now know this is 40.13, and your P star is 221.8. Okay, so your activity will equals to 0.181. Okay, and here our top is still the same, 40.13. At the bottom is this times your mole fraction of trichromethane in the solution phase, which is this guy, right? So it's multiplied by 0.287, and you do your calculation, this will give you a number of 0.631. Okay, so you need to show this, you need to show that, you need to show this to get full score for this question. All right, so yes.
So the homework says 24-48, right?
Yes. I know that some of you use a different version of textbook from
Yeah,
us.
so I can use a different problem.
Yeah, so, but that problem involves partition function.
No.
So yours did not, so we have three versions.
It was